Hello, this is a video for 9.3. So 9.3 talks about using the triangle congruence for side, side, side to find side lengths. So if we have this figure, which is made up of a lot of these little triangles right here. So we know that all of these triangles are congruent. This one doesn't have those two triangles, but if we were to draw a perpendicular bisector, it would make it work. So we look here. So this is 12. That's 18, that's 21.6. Since they're all congruent, then this one's also going to be 21.6, and so is this, and this side, and this side, and that side. Then if this is 12 right here, that one has to be 12, which means that whole length is 12 plus 12, which is 24. So then this could be 24. I could keep on going. I could say from here to there, let's see, that would be 24 plus 24, so that's 48. And I could do the whole length. So that's going to be 24 plus 24 plus 24, that's 72. So all these things you can figure out because of side, side, side. The other thing that you can figure out with this is angle congruence if you know all the sides are the same. So notice we know that all the sides are the same between these two triangles because of these tick marks. So 1, 1, 2, 2, 3, 3. And this triangle has two of the angles, and this one has the other one. So notice how they go. So across from the tick mark 1, this angle is 21.58. Across from the 2 tick mark, this is 28.61. And then you can see on this one across from the 3 tick mark is 29.81. So if I wanted to know the measure of angle A, I would just look at here and know that that was 129.81. If I wanted to know the measure of angle E, since it's across from the 1 tick mark, that means that it's going to be 21.58. So you can just do it like that. So then we will do the actual homework for it. So use these following triangles to complete the sentence. So if triangle ABC is congruent to triangle KLM, then the measure of angle B is, so I'm going to look here. On B is across from the one that's a length of 5. So I look on this triangle, I find the length of 5, and across from that will be 48. Then this one. So it has this made window pane thing, so we know that this bisects that. So we'd have angle. We have those two are the same. That one would be the same for this triangle and that triangle by the reflexive property. So we have to figure out why they're congruent and how we can prove that. So we would do, Aaron says that WZ bisects, so WZ bisects XY. So XZ is equal to XW. So that's not what that means, bisecting. Bisecting would mean that XZ is congruent to ZY or YZ. But so we're going to keep on going. So XZ is not congruent to XW. So we're going to keep on going. Samantha says that because of the size of the triangle are congruent, do we know? She wants to show that those two triangles, she wants to prove how the two triangular panels are congruent. So it doesn't say that they're congruent, so we can't do that. So let's do this one. YZ bisects XY. So WZ is congruent to XZ. Nope. Okay, let's see. WX is WY. That's true. That's what they said up here, right? WX, WY. And then we have WZ bisects XY. So this is what we want. XZ and YZY, YZ is congruent to itself. So it must be this one right there. Okay, so that was 9.3. The next thing on this is the checkpoint.